What's up, gang? It's your boy, the science lover. We're here for another episode of Quantum Dots. Stay tuned, won't be long, it's gonna be fun. Ciao.
What are quantum dots? Quantum dots, we can also call them nanoparticle of semiconductor crystals. They were found in 1981 by Alexei Ekimov. He's a Russian physicist working at the Vavilov State Optical. They were made from silicon or carbon, since both of these elements are so similar. This material is neither an isolator nor a conductor. The purpose of this video is to explain all the benefits and improvement coming from the usage of quantum dots in medicine. More precisely, what are the effects on the development of quantum dots in cancer research?
Nowadays, medical imagery has become a common practice thanks to machines such as MRIs, PETs, EEG scans, and has become a crucial tool since it enables us to have a relatively clear image of our inner selves. Now, these tools, although very powerful, are not state-of-the-art technologies and are presently being surpassed by newer and better innovations. In fact, scientists have discovered a novel nanotechnology called quantum dots, allowing us to take medical imagery to another level. Also, quantum dots have shown to have great utility when it comes to unmixing multiple fluorescent signals. The autofluorescence caused by the in vivo conditions can create an interference between the organism's fluorescence and the induced organic dye. Now, on the other hand, when it comes to quantum dots, the interference has no harmful effects on the actual image results, even when on a black background. Now, in order for this process to work, the nanocrystals are modified to best suit their desired task, as well as the in vivo conditions. So, firstly, they are covered in an antibody constructed by an amalgam of two coatings. The first one being an amphiphilic polymer, and the second being a coordinating ligand of tri- and octyl phosphine oxide. In addition, this polymer coat permitted quantum dots to keep their properties such as the emission spectra, the absorption spectra, and the fluorescence even in the most acid solutions resembling our stomachs. Now, next up is diagnosis of cancerous tumors. Quantum dots can also be used as bioconjugated probes, which potentially makes them useful for cancer diagnosis. Now, quantum dots' bright and stable fluorescent emission of light merges with the intrinsic high spatial resolution and fluorescence imaging have shown improvements in diagnostic assays that were done in the past. At this moment, there aren't many ways to diagnose cancer tumors, but some alternatives can be found, and in this case, protein biomarker detection, nucleic and acid biomarker detection, and high throughput manipulation. Protein biomarker detection is the ability to screen for cancer in the earliest stages, but this step needs highly sensitive tests to detect biomarkers, which are a measurable substance of carcinogenesis in an organism. Assay results for these new probes could be invaluable for protein detection in cancer diagnosis due to their high speed, ease of use, and low cost. It is for these reasons that QDs are ideal for biosensor applications thanks to their amazing resistance to photo bleaching, which gives access to continuous monitoring of a certain signal. To continue, nucleic acid biomarker detection is a way to improve diagnosis of cancer with the use of genomic screening of individuals' hereditary predisposition for certain types of cancers. It works by detecting mutated genes and some nucleic acid biomarkers for cancer in bodily fluids. Lastly, the high throughput multiplexing techniques consist of combining quantum dots of different colors into larger and bigger structures like a microbead to yield a code such as an optical barcode rather than using single quantum dots to identify single biomarkers. It is done by the combination of 6 quantum dots that emit colors and 10 quantum dots that have an intensity level for each color, which results to around 1 million different codes that are theoretically possible. The bead code identifies the sequence, while the intensity of the target signal corresponds to the presence and abundance of the targeted DNA sequence. This technique, we can not only try to find new biomarkers for diseases, but also lead the way towards a more simple genotyping of patients and for a cancer classification and personalized medical treatment of patients. Now, last but not least, targeted cancer treatments. Now, quantum dots are also used in targeting cancer treatments. Now, as soon as the tumors are discovered, quantum dots can serve as a delivery device for medication that directly targets the cancerous cells. Now, because of their unique properties, they can also be used to destroy cancerous cells by photodynamic therapy. The technology being used right now allows for QD probes to attach themselves to tumors using antibodies that adhere to the surface of cancerous cells. There are new innovations coming up about quantum dots every year. For this reason, scientists are taking in consideration quantum dots as medication carriers. In other words, they could deliver drugs directly to the affected area. They will become an alternative to magnetic imaging. But for now, most anti-cancer nanocarriers are chitosans, polymer nanoparticles, liposomes, and silicon nanoparticles. If scientists started using quantum dots as drug carriers, they would have to follow some regulations. For example, they will need to have no reactions with the drugs. They need a high drug loading capacity and an encapsulation efficiency. They should have a good biocompatibility and a low toxicity. If these constraints are respected, quantum dots will be able to identify, bind, and treat diseased cells and detect their trajectory in real time. And the best part is that they could link multiple functionalities on a single drug deliverer. To continue, the challenge with using quantum dots in vivo is that because this technology is very new, the side effects are still unknown. These nanoparticles can be highly toxic. While they are generally very stable, the protection layer that makes them non-toxic to healthy cells is damaged during long-term exposition to UV radiation. Now, that type of ray also makes them become cytotoxic. Photodynamic therapy, or PTD, is a form of treatment that uses light to activate a photosensitizer, which creates ROSs, reactive oxygen species, by energy transfer. When ROSs are created, the triplet oxygen is changed into its single form. That oxygen will then trigger cytotoxic reactions in the cell that lead to apoptosis. Photosensitizers are light-activated molecules that produce reactive oxygen species that causes damage to the cell structure to the point of causing yet again apoptosis. Now, quantum dots are considered good photosensitizers because they are non-toxic as well as easily sensitizable and can target specific cells.
Thank you, Mr. Stevenson, for that awesome information. Sadly, guys, the video is going to have to come to an end for us, but don't forget, if you want more information on quantum dots, I'll leave a link down in the description. Don't forget, hit that bell notification to stay tuned, subscribe, and don't forget, enter your stuff for the prize.
Ta-da! Ta-da! Ta-da!